In this video, I'm going to show how we can calculate the work done by a variable force along a straight line in an example problem and solution. We want to calculate the work done by a variable force F directed along the x-axis from x is equal to 0 to x is equal to 3 meters. The force f of x is equal to left bracket 9 minus x squared, right bracket, newtons. A plot of this function is now shown to the right. This function is a continuous function on the closed interval from x is equal to 0 to x is equal to 3. We can calculate the work done by the force F over the distance from x is equal to 0 to x is equal to 3 meters using the following formula. The work W done by the force F directed along the x-axis from x is equal to A to x is equal to B is equal to the integral from A to B of f of x dx. This formula takes into account the variation in force along the x-axis. In this example, we want to calculate the work done from x is equal to 0 to x is equal to 3 meters. So we set our lower limit of integration a equal to 0, and we set our upper limit of integration b equal to 3. This gives us the integral from 0 to 3 of f of x dx. F of x is equal to 9 minus x squared newtons. So we have the integral from 0 to 3 of 9 minus x squared dx. For the next step, I want to find an antiderivative of 9 minus x squared, and then use that antiderivative to evaluate the integral from 0 to 3. To find an antiderivative of 9 minus x squared, I want to find an antiderivative of 9, and I also want to find an antiderivative of x squared. We can use our integration formulas to help us to find an antiderivative. From the formula now shown, the indefinite integral of a constant k with respect to x is equal to kx plus c. From this formula, we can see that when we evaluate an integral with respect to x, we can use kx as an antiderivative of a constant k. 9 is a constant, so in this example, we can use 9x as an antiderivative of 9. To help us to find an antiderivative of x squared, we can use the following formula. The indefinite integral of x to the power of n with respect to x is equal to x to the power of n plus 1 divided by n plus 1 plus c for values of n not equal to minus 1. From this formula, we can see that when we integrate x squared with respect to x, we can find an antiderivative of x squared by adding 1 to the power and then dividing by that new power. So we can use x cubed divided by 3 as an antiderivative of x squared. I want to find an antiderivative of 9 minus x squared. An antiderivative of 9 minus x squared is equal to an antiderivative of 9 minus an antiderivative of x squared. So we can use 9x minus x cubed divided by 3 as an antiderivative of 9 minus x squared. This expression, now highlighted, is equal to left bracket 9 multiplied by 3 minus 3 cubed over 3, right bracket, minus left bracket 9 multiplied by 0 minus 0 cubed over 3, right bracket. 9 multiplied by 3 minus 3 cubed over 3 is equal to left bracket 27 minus 27 over 3, right bracket, and 9 multiplied by 0 minus 0 cubed over 3 is equal to 0. This expression, now highlighted, is equal to 27 minus 9, which is equal to 18. Our units are Newton meters, which we can express as joules. I've just calculated that the force F directed along the x-axis does 18 joules of work from x is equal to 0 to x is equal to 3 meters. This value of 18 joules is also the net area between the function curve and the x-axis, from x is equal to 0 to x is equal to 3. If you found this content useful, please subscribe to the channel to receive more content. Thank you very much for watching this video. See you next video.